Geotrig, this is lesson 12. Angles and diagonals in polygons. So this one should go pretty good here, pretty quick. In polygons, guys, it's very important you know this. The number of angles equals the number of sides. So every time you have a side, you have an angle that opens to that side, kind of in a way. I mean, maybe it's a little more sides you get. Sometimes it's a little harder to find that corresponding angle to it. But there will be. So if you have a 10-sided polygon, you will also have 10 angles that are associated with that. Makes sense, right? So remember, what's a convex polygon? It's the difference between a concave polygon. Convex means what? All the vertices, all your angle parts, right, point outwards. Concave, one or more points inward. It's like it's caved in. So as you can see, the triangle below you, all triangles are convex. They all point outwards. You can't make a triangle that is not. So your first one that I think that you could have a concave of would be a pentagon, right? So that would be concave instead of convex. Possibly. I guess that would be four-sided. So we could have a four-sided. We have a quadrilateral. That would be as well. But that's concave. Convex are when all the points are outwards. Does everybody remember that? I would hope so. So the biggest thing about a convex polygon, they both have interior and they have exterior angles. And it's a little bit different than what we're thinking here of what you think of interior and exterior. Interior is pretty straightforward. Everybody would understand what an interior angle is. That's the angle inside. If you're looking at the triangle there, I would agree, or hopefully you guys would also agree, that I have 3 interior angles, all at inside points, right? But then you guys would say, hey, there's also exterior. That means the angle on the outside. But the way the angles or exterior angles work, it's not, I'll change colors here, it is not all of this. Like, you can't say that the interior is something to its exterior and then they add up to 360. Because that's what it would be if I had that true. But the exterior angle, guys, actually just acts like I took the side and I continue it on. And so it basically forms a straight angle. Your interior angle and your exterior angle in this case would add up to what? 180. Okay? And it says that right in the bottom. Exterior angles are formed by extending one side at the convex polygon at a vertex. Or at the vertex. So the vertex would be the point here. So I extended the line all the way across, forming an exterior angle. Here, wait a minute. What happens if I extend it this way? It's the same thing. This now is E. But wait a minute. Both of those E's are the same because they are what? What's the name for that? Vertical angles. They are vertical angles to each other. Just like this would be I because the I's are vertical angles as well. Any questions to that? It's kind of straightforward for the most part. Once you get the idea or been told about it, you're like, okay, I can deal with that. So, next. Here's something cool. 2 things that are cool. That the sum of the measures of an interior angle and the exterior angle is 180. Oh, wait a minute. I already told you that, didn't I? Going back to that picture from before, I and E form a straight angle, which is 180. Going this way, I and E form a straight angle. Still, doesn't matter. It's 188 degrees because a straight angle is 180 degrees. Now Now the other one, which will go with the below there, is that the sum of the measures of the exterior angles in any convex polygon, so any exterior angles in a polygon is always 360. You guys want to know why? Well, I'm going to tell you anyways. So, here we go. Say you are standing at this vertex, this corner, right? Say this is my pool. I don't just get any regular old pool. I get a pentagonal type looking pool. That looks pretty cool. It's not even a regular pentagon, as you can see. So, this is my pool, and I'm going to walk around the edge. Just to show somebody I can walk around the edge of my pool. So, if I am walking from that point and walking in this direction, right? I would have to look in that direction. And at the point I get to here, I have to stop. And I have to turn my direction. Would you guys agree with this? I would have to now turn so that I'm looking in this direction. Keep walking until I get to here. And then turn again. To there. To there. To there. And then turn one more time. Wait a minute. What do you mean by turn? Well, again, I'm going to start here. If I'm facing off of my pool, or even if I'm facing, okay, we're facing this direction, so I'm walking here. But when I get to this corner, I'm facing here. That means I need to turn this amount of angle. I've just turned, what, 20, 30 degrees? And then I continue walking. I get to here. And now I need to turn this many. Looks pretty close to over 100, right? Maybe it's 90, 100 degrees. And then I'm going to go all the way down here. And then I have to turn that way. And then I get to the corner over here, and I have to keep turning, is it counterclockwise? And eventually, I get all the way to this point where I'm here, and I have to still face the same exact way, otherwise I do not make a complete rotation. One last time. And if I kept doing that, obviously it's a little easier if I demonstrate this in class. So I'm going to do that while I'm recording live. Here's my pool. If I start here, I'm going to walk to the point here, turn. I'm going to walk here, turn, turn. Am I back to exactly where I started? No. Not quite until I make my final turn. But what did I actually just do? I just turned in one big circle, and one circle equals how many degrees? 360. So, that's 360 degrees. We should also remember that if I was talking about a triangle, I'd only have how many interior angles? 180 inside. But how many would be outside? How many angles outside? Degrees outside? How many degrees are the exterior angles of a triangle? 360. It's always 360. They're going to trick you guys. They're going to put a question in your homework that says, find the sum of the exterior angles of a 27-agon. All you have to do is say 360. Now, if they ask you for the interior angles, well, now we got to be a little bit trickier. So we need to come up with some kind of way to figure that out. Because yes, a triangle has 360 degrees in it. Or no, sorry, wow. A triangle has 180 degrees in it. Does a square have 180 degrees? How many degrees are in a square or a rectangle? 90, 90, 90, 90, which is 360. So wait a minute. That almost seems like it doubled it. What about a pentagon? Does that double it again? So maybe that should be 720? It doesn't. So let's see if we can figure something out here. So, we want to know the sum of the interior angles of any polygon, convex polygon. Make sure you know that. So we already said here that if it's a triangle, it would be 180, right? If it's a rectangle, we said it was 360. But now we move up above. I have a pentagon, I have a hexagon, and then I have a, is that an octagon?
No.
One. It might be a little tougher. I'm not sure what this one is. One. Oops. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A decagon? It's a decagon. Okay. So, how can I do this? Turn them all into triangles, as it says, right? You can use triangles to determine the sum of the interior angles. How do I change it into triangles? I would rather not make a point in the center and try making triangles. That would get a little crazy. Now, if they're regular, like the next, I think these two look like regular polygons, which means all the sides and all the angles look the same, right? But the pentagon is not that way. So there's got to be a different way here. And the reason, another reason that there would not choose to put it in the middle is because you wouldn't have the overlap. So my suggestion is to pick one vertex and connect it to all of the others that you can within the polygon. How many triangles are formed? 3. How many degrees are in a triangle? So if there are 3 triangles
360. No.
at 180,
540.
540. So it's 540. Now you may be asking, well, why is that any different than what Abby was asking? Why can't I do this? And that forms 5 triangles, yes? Don't write this down. Don't write this down, guys. Here's the problem with this method. Go on. Right. This method, guys, adds angles here. These angles are not really part of the interior angles of this polygon. Versus, if I go back, whoops, if I go back to these, oh, that's a bad line. That's an even worse line. If I go back to here, look at it. Would you guys agree that this angle plus this angle plus this angle is that whole entire one? Can I do the same thing over here? That the 2 angles in these triangles just make up the larger one? And the larger one here? So it seems that every vertices interior angle has a partner from another triangle that would help create the whole entire thing. So therefore, when we create the 3 triangles, every angle from every triangle is used in the larger polygon. Do you see that? Versus if I put a point in the middle, we got some that are not used. So how do you handle that? You can't. So let's do the same thing with the next 2 examples. How many triangles can I make with this one? 4. 4 times 180 is what? 720. Next one. This is a fun one. 1, 2, 3, 4, 5, 6, 7. Yeah? So how many triangles am I making though? 1, 2, 3, 4, 5, 6, 7, 8. Correct. And 8 times 180 is?
No.
1,000?
It's 1440.
1440?
Mm-hmm.
1,440 degrees? What if there was a 20-sided? How many degrees altogether inside?
2,880.
Can we just double it like that? I don't know. What if it was only 8-sided?
That is 8.
No, that's 10, remember?
Oh, that's your intentional one. Like, I thought, never mind.
What about 7-sided? So, here's the thing. Let's write these down. We talked about 3-sided, 4-sided, 5-sided, 6-sided, even all the way up to 10 sides, right? There's some numbers that went on in between here. That's the number of sides. How many degrees? 180, 360, 720. Whoops, I jumped off. 540, right?
Yeah.
540, 720, dot, 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 1440. I don't know if that 1440 won 10-sided because we jumped. I don't know if it's really helpful. What's the connection here? What am I doing every single time? I'm not doubling it every time, that's for sure. I'm raising it by how much? 180. So this is, wait, so you're saying this is 180 times 1? This is 180 times 2? 180 times 3? 180 times? How about this one? 8. What happens if I go to n sides? What seems to be happening with our connection between the sides? And how many times we multiply it to 180?
180 times n minus 2.
It's n minus 2. There's n. This is our sides. The number of sides, if I subtract 2, I get 1 multiplied by 100, or 180. 4. 4 times 2 is 2. 5 minus 2. So, the formula is 180 times n minus 2. There's your formula, guys. So if I wanted to know an 8-sided convex polygon, how many interior angles there are, you would say it'd be 8 minus 2, which is 6, and 6 times 180 happens to be, using your calculator more than likely, 8's not up there.
You said 6.
If it's 8-sided,
Oh, sorry.
so that'd be 6. So you definitely know it's between 720 and 1440. 1080?
Yep.
I did that in my head.
Yes.
Okay? Is it making sense, guys? So that's your formula. We did all of that just to come up with a formula. Okay, guys, now we got to do the same thing for diagonals. What's a diagonal? Connecting vertices. So guess what? Maybe we should start a little bit more, a little bit simplified from here yet. Let's just get this out of here. What if I went to a 3-sided one? Are there any vertices I connect that are not already connected? No, there's 0 of them. But if I get to a rectangle, I get 1, 2. You guys okay with that? Then we step up to a 5-sided. Then we have 1, 2. Any more? 3, 4. Oh, wait. There's more.
2 on across the top.
5. Ooh, that turns into 5? Yeah, that is kind of cool, huh? Here we go. Let's start with the hexagon. 1, 2, 3.
Okay.
4, 5, 6. Any others? That one? So there's 6. Wait, there is another one there?
Yeah.
Oh yeah.
Where?
The only cross one.
No, I haven't got there yet. I'm only using. Notice, guys, I started off with the bottom left vertex, and I'm only connecting to the ones that I can here that have not been connected already. And then I walked over to this vertice. Is that okay? So I think there's only 6 total so far.
Yeah.
I'll move to this one next. Now, what you guys would say? 7. Whoops. 8.
Yes.
Okay. Moving along. We're at 8. Starting here. I think this one are here, right?
Yep.
9. Any others?
No.
Notice each vertice is actually connected to how many others? 3 others. But you can't recount a connection once it's already been made, right? So this one only had how many? 9. Only had 9, right? Whoa, there's that 10-sided object thing again. Oh wait, we forgot to write 2 on this one. This one's gonna be a mess, isn't it? 1, 2, 3, 4, 5, 6, 7.
Your lines got really perfect.
Yes, they did. 8, 9, 10, 11, 12, 13, 14. Oh, whoops. That was not supposed to happen.
I didn't see that one.
Where are we at? 14?
Yeah.
15, 16, 17, 18, 19, 20? Oh my goodness. We already did purple. Green. We're at 20? 21, 22, 23, 24, 25. 26, 27, 28, 29.
I can't even tell anymore.
What is that? 29?
Yeah.
30, 31, 32.
Yeah.
33, 34. 35. I think I got them all. I'm not sure. I got 35. Some people say you got 34. It looks really cool, doesn't it? Especially when you color code it like that. But yes, really easy to get lost, yes? Hey guys, I'll give you a 100-sided one. Go for it, right?
So there's an easier way to do it.
There's obviously a formula for this one as well, just like last time. So let's list these things, okay? When it's 3, 4, 5, 6, and then 10. We don't know if 10's right, but we know the rest of them are right. 0, 2. That's a 5 down to 3. How many do we have there? 5, 9, and we think that was 35. Nice big leap, doesn't it?
Yeah.
Well, we didn't have 7, 8, or 9 in there. Well, there's the number of sides, and there's the number of diagonals. Oh, this one's a little tougher.
Oh,
We're running out of time, but number of diagonals equals n times n minus 3 divided by 2. Where n is the number of sides. Guys, what's 3 times 3 minus 3 divided by 2? What's 3 minus 3? 0. And 0 times 3 divided by 2? 0. So that works. 4 times 4 minus 3 is 1. So 4 times 1 is 4 divided by 2? 2. You're starting to see that it does work.
5, 10,
Guys, page 95, lesson 12, 3 through 12, and 23. Have a fantastic night.